Hello and welcome to today's webinar on data analytics and visualization tools. Good evening to all of you. I, Pranand Patil, welcome you to today's webinar on data analytics and visualization tools. So, today I am going to make you familiar with different data analytics and visualization tools whose demand is rapidly growing in IT industry like cloud computing, artificial intelligence, machine learning, CCNA. Data analytics is also one of the latest emerging trend in IT industry. So the first slide. So the first slide is about what is data analytics and visualization. Data analytics involves processing data to discover trends, patterns, and actionable insights. Data visualization makes this data easier to interpret through charts, graphs, and dashboards. Real-world applications of data analytics and visualization are in healthcare sector. It is used to predict patient readmissions. In retail sector, it helps manage inventory and forecast demand. In finance sector, it identifies fraud. So, the first data analytic tool with which I am going to make you all familiar is Power BI. Power BI, developed by Microsoft, has rapidly become one of the most popular BI tools worldwide. Its deep integration with the Microsoft ecosystem, including Excel, Azure, and Teams, gives it a unique advantage. Power BI offers a user-friendly interface with drag and drop functionality for building dashboards. It supports connections to hundreds of data sources ranging from SQL databases to cloud services like Salesforce and Google Analytics. One of the Power BI's standout features is its affordability, making enterprise analytics accessible to smaller businesses. Its natural language query feature Q&A allows users to type questions and receive instant visual answers. Power BI also supports advanced DAX. DAX stands for data analysis expressions, enabling complex calculations and measures. Organizations use Power BI for finance, marketing, operations, and HR analytics. Its mobile application allows decision makers to access dashboards anywhere, ensuring data-driven decisions on the go. Collaboration is central to Power BI with seamless integration into Microsoft Teams and SharePoint. Another strength is frequent updates. Microsoft releases new features monthly based on user feedback. Power BI also integrates with artificial intelligence services, enabling predictive analytics and anomaly detection. Its security features include row-level security and compliance with enterprise standards. Another advantage is Power BI's embedded analytics, allowing developers to integrate dashboards into custom applications. In government sector, Power BI is used for transparency and citizen engagement. In healthcare sector, it supports real-time monitoring of hospital resources. Its scalability makes it suitable for both startups and Fortune 500 companies. Power BI's community is large and active, sharing custom visualizations and best practices. A key limitation is performance with extremely large datasets, though premium versions mitigate this. Another drawback is the complexity of DAX, which requires learning for advanced use cases. However, Power BI's value for money proposition is unmatched. Its close ties with Excel make it easy for existing users to transition. Power BI also supports hybrid deployments, connecting on-premise and cloud data seamlessly. Organizations benefit from its ability to unify disparate data sources into a single source of truth. In education, Power BI is used to teach analytics skills to students. Its global adoption ensures that Power BI expertise is in high demand. With ongoing innovation, Power BI continues to expand its role in self-service and enterprise BI. In conclusion, Power BI combines affordability, accessibility, and enterprise power, making it a dominant force in the BI market. And after learning Power BI technology, you can land job roles like Power BI developer, BI analyst, report developer, etc. So the second data analytic tool with which I am going to make you all familiar is Tableau. Tableau has long been recognized as a pioneer in the field of data visualization. Founded in 2003, it revolutionized analytics by making data accessible through visual exploration. Its drag and drop interface allows users to build dashboards without writing code. Tableau's strength lies in its ability to connect to a wide range of data sources from Excel and SQL databases to big data platforms like Hadoop. Its visualizations are highly interactive, enabling users to drill down, filter, and uncover insights quickly. Tableau Public has also become a platform for sharing visualizations with the global community. A hallmark feature of Tableau is its advanced calculated fields, which allow complex logic to be applied within visualizations. Organizations use Tableau across industries. Retailers analyze sales performance, banks track compliance, and healthcare providers monitor patient outcomes. Tableau also supports geographic analysis with built-in mapping capabilities. Another strength is its ability to handle large data sets through in-memory processing. Tableau's visualization library includes bar charts, scatter plots, heat maps, and more advanced types like waterfall charts and box plots. Its storytelling feature allows users to build data-driven narratives for presentations. Tableau integrates with R programming language and Python programming language, enabling advanced statistical modeling. Collaboration is a major advantage with Tableau Server and Tableau Online, providing centralized platforms for sharing dashboards. Its user community is one of the most active in the analytics world, sharing tutorials, templates, and best practices. Tableau also supports mobile analytics, allowing dashboards to be accessed on the go. One limitation is cost. License can be expensive for small organizations. Another drawback is the steep learning curve for advanced features. However, the trade-off is unmatched flexibility and power in data visualization. Tableau continues to innovate with AI-driven features such as Ask Data, which allows natural language queries. Its acquisition by Salesforce has expanded its ecosystem, integrating with CRM data for deeper insights. Tableau Prep extends the platform into data preparation, simplifying ETL workflows. For government agencies, Tableau helps with transparency and citizen engagement. In education sector, students use Tableau to learn storytelling with data. Its global popularity ensures that Tableau skills are highly valued in the job market. Tableau dashboards often become the centerpiece of executive, executive decision making. Its flexibility allows both technical and non-technical users to uncover insights. Tableau's combination of rich visualizations, community support, and enterprise features make it a leader in the BI space. In conclusion, Tableau set the standard for modern BI and continues to shape how organizations turn data into actionable intelligence. And after learning Tableau technology, you can land job roles like Tableau developer, data visualization specialist, business analyst, etc. Now, the third data visualization and sorry. Now the third data analytic and visualization tool with which I am going to make you all familiar is Apache Superset. Apache Superset is a powerful open source business intelligence tool that is gaining popularity as an alternative to commercial platforms developed initially at Airbnb. It is now an Apache Software Foundation project supported by a vibrant community. Superset allows users to connect to a wide variety of databases, including PostgreSQL, MySQL, Presto, and big data systems like Hive and Druid. Its SQL Lab provides an interactive environment for running queries and visualizing results. Superset offers a rich gallery of visualization options from standard bar and line charts to advanced heat maps, tree maps, and geospatial visualizations. Dashboards in Superset are highly customizable and can be shared across teams. One of its biggest advantage is cost. Being open source, it eliminates licensing fees. This makes Superset particularly attractive for startups and academic institutions. It also scales well, capable of handling large data sets through integrations with distributed SQL engines. Superset supports role-based access control for enterprise security needs. Another benefit is its extensibility. Developers can create custom visualization plugins tailored to business requirements. Superset's architecture is cloud native, making it suitable for modern data stacks. Organizations use Superset for monitoring operations, financial analysis, and customer behavior insights. Its intuitive, its intuitive interface enables non-technical users to create dashboards with minimal training. Collaboration features allows dashboards to be embedded in web applications or shared through links. Superset integrates smoothly with Python workflows, enabling data scientists to combine with pandas and machine learning pipelines. A key limitation is the complexity of setup, which may require technical expertise compared to plug-and-play tools. Another drawback is that community support, while strong, cannot match the dedicated customer support of commercial BI vendors. Still, Superset's transparency and adaptability make it a compelling choice. In government and education, Superset is used to publish open data dashboards for public access. In healthcare, it supports patient data monitoring and hospital operations. Its strong, its sorry, its strong SQL-based foundation appeals to analysts who are comfortable with querying. Superset's popularity is also fueled by its compatibility with Kubernetes and Docker for scalable deployments. The active development community ensures continuous improvement and innovation. Superset aligns with the trend of organizations seeking sorry, Superset aligns with the trend of organizations seeking open source alternatives to reduce costs and increase flexibility. For teams prioritizing control, customization, and scalability, Superset is an excellent option. In conclusion, Apache Superset proves that sorry, sorry. In conclusion, Apache Superset proves that open source tools can rival commercial BI platforms in power and functionality. It empowers organizations to own their analytics stack without vendor lock-in while fostering innovation and collaboration. After learning Apache Superset technology, you can land job roles like data engineer, BI developer, open source, analytics engineer, etc. Now, the next data analytic and visualization tool with which I am going to make you all familiar is Google Looker. Google Looker has emerged as a modern business intelligence BI platform designed for the cloud era. Unlike traditional BI tools, Looker emphasizes a modeling layer that ensures consistent metrics across an organization. This modeling is powered by LookML, a unique language that defines data relationships and business logic. Looker integrates seamlessly with Google BigQuery and other modern cloud databases, making it highly scalable for large datasets. A standout feature of Looker is its self-service analytics, where business users can explore data without relying on IT teams. Its drag and drop interface makes it easy to generate reports and dashboards quickly. Looker also provides embedded analytics, allowing organizations to integrate dashboards directly into applications and customer portals. Collaboration is another strength. Users can share dashboards, schedule reports, and integrate with tools like Slack and Gmail. Looker's real-time analytics enable decision-making based on the latest data instead of stale reports. Another advantage is governance. LookML ensures that metrics like customer lifetime value or gross margin are defined consistently company-wide. This avoids the common problem of multiple versions of truth seen in other tools. Looker supports advanced visualizations ranging from heat maps to geographic maps, providing flexibility in storytelling. It also supports predictive analytics through integration with machine learning platforms. Security is enterprise grade with role-based access and compliance with global standards. Looker is also developer-friendly, offering APIs and SDKs for custom applications. Organizations use Looker for a wide range of cases. Retailers analyze supply chains, banks monitor risk exposure, and media companies track audience engagement. Its native integration with the Google Cloud ecosystem provides a significant advantage for organizations already invested in GCP. Looker Studio, a free companion product, extends reporting capabilities to smaller teams. The acquisition of Looker by Google has accelerated innovation and positioned it as a strong competitor to Tableau and Power BI. However, Looker's pricing can be a barrier for smaller businesses. Another limitation is its reliance on modern SQL databases, making it less suitable for legacy systems. Despite these, Looker's combination of scalability, governance, and ease of use makes it a favorite in the cloud BI space. Its flexibility allows both analysts and business users to gain insights at their own pace. Looker's, Looker, sorry, Looker also excels in real-time customer analytics, where streaming data can be visualized instantly. By combining governance with flexibility, Looker bridges the gap between IT control and business agility. In short, Google Looker redefines BI for the modern cloud-first organization. It empowers businesses to scale analytics, ensure consistency, and make faster decisions based on reliable data. And after learning Google, sorry, and after learning Google Looker technology, you can land job roles like Looker developer, cloud analyst, analytics engineer, etc. So the next data analytic and visualization tool with which I am going to make you all familiar is Excel. Excel has stood the test of time as one of the most trusted tools in data analytics. It is often the first tool that professionals are introduced to when working with data. Despite being decades old, Excel continues to evolve with powerful features. Its simplicity and accessibility make it popular across industries and professions. Excel is excellent for handling small to medium-sized data sets. Its grid format provides a visual and intuitive way intuitive way to organize data. Users can apply formulas like sum, average, and VLOOKUP to calculate metrics instantly. One of its most powerful features is the pivot table, which allows users to summarize large amounts of data dynamically. A sales manager, for example, can use pivot tables to view quarterly performance across regions. Charts and graphs in Excel bring numbers to life. Line charts, bar graphs, and pie charts are commonly used for performance monitoring. Conditional formatting is another favorite feature. It highlights trends and anomalies visually. Excel also supports data validation to ensure accuracy when multiple users input information. Macros and Visual Basic for applications extend Excel's functionality further. Through automation, repetitive tasks like generating weekly reports can be completed in seconds. Excel integrates well with other systems, including SQL databases and APIs. This makes it versatile. This makes it versatile for importing and analyzing external data. In finance, Excel remains unmatched for budgeting, forecasting, and financial modeling. In marketing, it is used to track campaign performance and ROI. In HR, Excel supports workforce planning and payroll analysis. One of Excel's main limitations is scalability. It struggles with datasets larger than a million rows. However, for many business problems, Excel speed and simplicity outweigh this drawback. Another limitation is collaboration. Though cloud-based Excel in Microsoft 365 addresses this to an extent, Excel remains a powerful prototyping tool even in organizations that rely on advanced BI platforms. Professionals often start analysis in Excel before moving to larger tools. Its familiarity reduces training costs, making it accessible to all levels of staff. For quick what-if analysis, Excel remains unmatched. Scenario Manager and Goal Seek provide powerful forecasting capabilities. Excel is also invaluable in education, where it is used to teach fundamental data concepts. From budgeting at home to financial planning at Fortune 500 companies, Excel is everywhere. Its continued relevance proves that sometimes simplicity is the ultimate sophistication. In summary, Excel is not just a spreadsheet, it is the backbone of countless business decisions. After learning Excel technology, you can land job roles like entry-level analyst, reporting specialist, business support analyst, etc. Now, the next data analytic tool I'm going to make you familiar with is SQL. SQL stands for Structured Query Language. SQL has remained the cornerstone. SQL has remained the cornerstone of analytics for decades. It is specifically designed for managing and querying relational databases, making it indispensable for data professionals. SQL allows users to retrieve, filter, and aggregate data from vast datasets with remarkable efficiency. For instance, with just a few lines of SQL code, an analyst can find the top-selling products across multiple regions. One of the strengths of SQL lies in its universal applicability. Whether you are using MySQL, PostgreSQL, Oracle, or SQL Server, the fundamentals remain the same. This makes SQL a transferable skill across industries and platforms. SQL also supports advanced querying features such as nested queries, window functions, and stored procedures. These allow for deeper analysis like finding, moving, averages, or ranking customers by revenue. Many organizations build complex reporting pipelines entirely around SQL. A critical advantage is that SQL is declarative, meaning users specify what they want and the database engine figures out how to get it. This simplicity allows non-programmers to access and analyze data without advanced coding skills. However, for power users, SQL also provides robust optimization options like indexing and query tuning. SQL is not just about querying, but also about managing data integrity. Constraints, keys, and normalization ensure accuracy and consistency of stored data. Another reason SQL is vital is its integration with visualization tools. BI platforms like Tableau, Power BI, and Superset often rely on SQL queries in the backend. Python's Pandas library even allows direct execution of SQL queries in the backend. Python's Pandas library even allows direct execution of SQL queries for hybrid workflows. A common use case is business reporting. HR teams might use SQL to calculate employee attrition, while finance teams calculate ROI. SQL is also central to ETL, extract, transform, load processes, where raw data is cleaned and prepared for analytics. With the rise of big data, SQL has evolved too. Platforms like Hive and Spark SQL extend SQL syntax to distributed environments. This means analysts can use familiar SQL commands to analyze petabytes of data. SQL's readability is another key advantage. It resembles natural language, making it approachable. Even executives, even executives can understand a select or where clause at a glance. Despite the rise of Python and R, SQL remains irreplaceable because databases will always need structured queries. Its backward compatibility ensures that SQL knowledge gained today will be valuable for decades. In many job descriptions for data analysts, SQL is listed as a must-have skill. In short, SQL is the language of data itself. From startups to Fortune 500 companies, SQL is used daily to answer critical business questions. It is a bridge between raw data storage and meaningful analysis. Consider an e-commerce company. SQL queries can reveal not only who the top buyers are, but also when they are most active. This insight can shape marketing campaigns and product launches. SQL is also critical in compliance, where accurate reporting is required for audits. For example, banks use SQL to produce daily financial reports to meet regulatory standards. The sheer stability and maturity of SQL make it a trusted companion in the analytics journey. Thus, SQL is more than just a language, it is the foundation of the modern data ecosystem. And after learning SQL technology, you can land job roles like SQL developer, data analyst, database engineer, ETL developer, etc. Now, the next data analytic tool I am going to make you all familiar with is Python. Python has become the Swiss Army knife of data analytics and visualization. It is widely adopted because of its simplicity, readability, and vast ecosystem of libraries. With libraries like Pandas, analysts can clean, manipulate, and aggregate data efficiently. Visualization libraries such as Matplotlib and Seaborn provide flexible ways to create charts and graphs. Plotly and Bokeh add interactivity, allowing dashboards to be shared with non-technical users. Python integrates seamlessly with machine learning libraries like scikit-learn and TensorFlow, bridging the gap between analytics and artificial intelligence. Another advantage of Python is automation. Scripts can handle repetitive tasks like generating weekly reports or scraping data from websites. Jupyter Notebooks have revolutionized how analysts work by combining code, visualization, and narrative text in a single document. Python's integration with SQL APIs and big data platforms make it a universal tool for modern workflows. In finance, Python power risks, sorry, sorry, in finance, Python powers risk models and algorithmic trading systems. In healthcare, it is used for patient analytics and predictive diagnosis. In marketing, Python enables customer segmentation and churn prediction. Its community-driven growth ensures a constant flow of new tools and improvements. For example, libraries like Altair simplify the creation of declarative charts with minimal code. Python also supports advanced visualizations like heat maps, network graphs, and geographic maps. Its open source nature reduces costs for organizations while providing cut-edge capabilities. Python is also favored in academia, where students learn data concepts through real-world datasets. Another strength is reproducibility. Python scripts can be versioned, shared, and scaled easily. Frameworks like Dash and Streamlit turn Python scripts into interactive web apps for analytics. This allows teams to build lightweight dashboards without investing in enterprise BI software. Python's versatility extends to cloud computing, where AWS, Azure, and GCP offer native Python integrations. One challenge is performance with extremely large datasets, though libraries like Dask mitigate this. Python also relies on programming knowledge, which can be a barrier for some business users. However, its flexibility and power make it the go-to tool for data scientists and analytics. Sorry, for sorry. However, its flexibility and power make it the go-to tool for data scientists and analysts alike. Unlike GUI-driven tools, Python provides complete control over the analysis process. It is also a favorite in data engineering for building ETL pipelines. In journalism, Python helps create compelling visual stories with open data. The language's role in open science promotes transparency and accessibility of research. With its global popularity, Python skills are highly valued in the job market. Whether building a quick chart or a full-fledged analytics application, Python delivers. It empowers individuals and teams to unlock insights from data in innovative ways. In short, Python is not just a programming language, it is the backbone of modern analytics workflows. It connects raw data, statistical modeling, and it connects raw data, statistical modeling, and interactive visualization into a unified ecosystem. Its constant evolution ensures that Python will remain a dominant force in data visualization for years to come. And after learning Python programming language, you can land job roles like data scientist, machine learning engineer, automation analyst, Python developer. And let me tell you one important point, or you can say minute detail related to Python programming language. So that minute detail is, for example, if in C programming language, you initialize two different variables with the same value, then they are stored at two different memory locations. That is, for example, in C programming language, if you initialize A and B, two different variables with the same value, 10, then in that case, what happens at the computer's backend is a separate unique memory address is allocated for 10 values stored in A variable, and another separate unique memory address is assigned for 10 values stored in B variable. But if you consider this same scenario in case of Python programming language, first of all, in Python, memory is divided into two parts, stack and heap, where stack stores values and heap stores memory reference or memory address. Now, if you consider the same scenario in case of Python programming language, which I told you previously in case of C programming language, in that case, what is going to happen at the computer's backend is a separate unique memory address will be allocated for 10 values stored in A variable. But the 10 values stored in B variable is going to point to the unique memory address assigned for 10 values stored in A variable. And from this example, we can conclude that Python consumes less memory compared to C programming language, since in Python, duplicate or repetitive values share identical memory address or common memory address. Since from this example, we can conclude that duplicate or repetitive or same values in Python programming language share common memory address or identical memory address, which is also one of the important feature that why people choose Python programming language over other programming languages. And after learning Python programming language, you can land job roles like data scientist, machine learning engineer, automation analyst, Python developer, etc. So tools working together. So the next slide is about tools working together. Real-world data workflows use a combination of tools: SQL for querying, Python for cleaning and modeling, Tableau and Power BI for visualization, Excel for summaries, Superset or Looker for embedding or engineering specific dashboards. Now, the learning path for a candidate who wishes to pursue a career in data analytics and visualization tools is begin with Excel and SQL to understand data structure and querying. Begin with Excel and SQL to understand data structure and querying. Move to Power BI or Tableau for dashboard and reporting skills. Learn Python for automation, deeper analysis, and predictive modeling. Explore Looker and Superset for advanced modeling and cloud native or real-time analytics. You can also pursue. You can also pursue certain certifications like Power BI, Tableau, etc. Now, career opportunities after learning all the data analytics and visualization tools with which I made you all today familiar are data analyst, which job role can land you a 5 to 8 LPA salary in India. BI developer, which job role can land you a salary of 6 to 10 LPA in India. Python developer job role, which can land you a range of 8 to 12 LPA salary in India. Data scientist job role, which can land you a salary of 10 to 20 LPA in India. Analytics engineer, which can land you a salary of 8 to 15 LPA in India. Now, real world applications are in retail sector, Power BI is used for storing sales tracking, inventory alerts. In healthcare sector, Python and SQL is used to build risk prediction models. In fintech sector, Looker dashboards show user investments and real-time profit or loss. In startups, Apache Superset is used by developers to monitor usage metrics. So final thoughts about today's webinar is no single tool is sufficient. No single tool is sufficient. Combine strengths SQL plus Python plus visualization. Build real-world dashboards from open data or your company data. Share your work publicly on platforms like GitHub, LinkedIn to build credibility. Aim to be a storyteller with data, not just a number cruncher. And finally, I would like to tell you that we at ABC Trainings welcome you if you wish to pursue a career in data analytics and visualization tools. At ABC Trainings, we not only make you familiar with basic concepts, but also with advanced concepts, and also make you familiar with real-time applications or real-world applications, which is important to survive in today's competitive world. So that's all for today. Thank you for listening to me patiently. Let's meet in the next session.